Machine Learning for Absolute Beginners. Chapter 8. Logistic Regression. In the previous chapter, we explored how linear regression quantifies relationships between variables to predict a continuous outcome, such as the total bill or the number of guests. However, when we want to predict a categorical variable, like whether a customer is new or returning, we use a different technique, logistic regression. Unlike linear regression, where the dependent variable is continuous, logistic regression deals with discrete categorical variables. It is a supervised learning technique that makes qualitative predictions, classifying data into distinct categories rather than predicting exact values. Understanding logistic regression. Logistic regression is commonly used for binary classification problems where there are two possible outcomes. Examples include predicting whether an email is spam or not, detecting fraud, diagnosing diseases, or identifying emergency situations. The strength of logistic regression lies in its ability to handle binary classifications effectively. The sigmoid function. The core of logistic regression is the sigmoid function, which maps any input into a value between 0 and 1, forming an S-shaped curve. This function calculates the probability of a given independent variable, resulting in a specific class of the dependent variable. Logistic regression in action. After applying the sigmoid function, data points are assigned to classes based on their calculated probabilities. Similar to linear regression, independent variables used in logistic regression can be continuous or categorical. Categorical variables must be numerically encoded, often using techniques like one-hot encoding. While linear regression uses a hyperplane to predict numeric values, logistic regression uses it to establish a decision boundary, dividing data into classes. Independent variables are plotted along the axes, and the class of the dependent variable is determined by the position of data points relative to this boundary. Multinomial logistic regression. For scenarios with more than two possible outcomes, multinomial logistic regression is used. This method handles multi-class problems, such as educational levels, for example, pre-undergraduate, undergraduate, postgraduate. While logistic regression is powerful for binary classification, other algorithms like decision trees or support vector machines may be more suitable for complex multi-class problems. Tips for using logistic regression. Data quality. Ensure the dataset is free of missing values and that independent variables are not strongly correlated with each other. Sufficient data. Aim for 30 to 50 data points per output class to ensure accuracy, totaling 60 to 100 data points for binary classification. Limitations. Logistic regression is less effective with large, messy datasets containing outliers and complex relationships.